followed by the alarm bell, right? So then you introduce a delay, right? This is basically it's 1 second delay, right? So basically every 1 second, right, you want to bring a line, right? So hello something, hello followed by alarm bell. So if you bring up this output, right, in the serial monitor, you will get this kind of output, like hello 1, hello 2, hello 3, hello 4, right? And so on. Right? So I think this one is for now, right? It should be simple enough. I don't need to do a demo again, right? Yeah, you understand, right? No issue, right? Okay. So basically, this is how you can use a serial monitor. So as I mentioned to you earlier before, right? Actually, serial monitor, right, can be used for debugging. You know, some of you have already asked me, right, in the lab. For example, like when you see some errors, right, from your program, how do you debug? So actually, the IDE, right, you use, it actually is not a good debugger, right? Because when the error message show you, right, let's say you have a missing column, you have missing bracket, something, right? So actually, it did not tell you where it is. You have to read through your code, right, and find out the errors. Right? So the IDE you are using, right, actually is not a good debugger. That's it, right? But if you want to do a debugging, right, so basically you can use some of functions from the serial monitor, right? Basically you can, for example, you can pick up the value of the variable. Okay, then you can see what is the current value, right? Then you can do some debugging. Okay, so for example, right, if you have this function, right, this function we have discussed before, basically is the button press function, right? So because I mentioned to you before, right, if you define your input as input 1, right, so basically the logic is a bit first. So basically when you press the button, the output is low, right? When you don't press the button, the input is low, right? So if you don't press the button, input actually is high, right? That's the input what means, right? So it's a bit reverse logic. Now, let's say if you want to write a function to make the logic, right, to be a normal logic, right? So you can write the function like button press. So basically, first you want to read the reading, right? Read the input from the button pin, right? So you get the reading, you assign it to the button setting, right? So when the button setting is high, so when the button setting is 1, right? So you want to return 0, right? That means your button did not press. Your button is not pressed, right? So when the button setting is 1, right? Else you want to return 1, right? So 1 is high, right? Okay. So now, if you want to do a debugging, right, so you can always check what is the value, right, of the button setting, right? So you can print out the value, right, of the reading to the serial monitor. Then you can see what is the output, right? What is the input you are expecting, right? So in this case, actually you can do some debugging in a sense, right? So you bring out the value of the button setting to the serial monitor, right? So you can see whether the reading, right, is what you expect. Okay? Of course, I mean, if you have your own variables, right, you can also bring out the value of variables, right? So in this way, you can do some debugging. Okay? So you can read the display, right, in the serial monitor, right, and you can see if the value is correct. And the debugging, right, using the serial monitor, right, is not the most elegant way, right, but it's very simple, right? And it's quite effective actually. Actually, for myself, actually, I use the serial monitor quite often, especially whenever I write a new program. But the thing is, all this print line, additional print line, right, you have to remove it, right? Because this is additional lines for your debugging, right? So when you are sure your program is working, right? So you have to remove the print line from your original program. Otherwise, your program becomes very messy. Okay, and of course, there are more advanced debuggers in the market today. So if you are experienced programmer, right? Let's say you use the Visual C++ compilers from Microsoft before, right? Actually you will see the debugging functions, right? It actually is more advanced in those professional programming environments. Right? For example, like actually you will have the option, right, to do the debugging line by line, right? So you can say, okay, I only want to debug the program, right, up to this stage and next stage, for example. Right? So the professional debuggers, right, they have this kind of function. Right? Then let's say you may ask, right, can I have such function in my Arduino programming? Right? So actually you can add. Right? So one example is you can download this Uno ARDU, right? RDU-C, right? So this is the debugger actually is more advanced than our IDE, the tools you use, right? Okay. Okay. Next, we want to discuss the data logger a little bit. So I want to revise a little bit. Okay, so last time we discussed the switch box, right? So we say the ideal case you want the switch to be like this one, right? So initially it's 1. So if you press your switch, you change to 0, right? So that's the ideal case. But what actually happens is you always have the transition period, right? So if you go from 1 to 0, you will see something like this one, right? And goes to 0, right? So you always have this kind of transition period, which is what we call a switch box, right? So we have discussed this before, right? So you may ask, can we see this one? Can we see this one happen using the Arduino board? Right? And we have discussed, right? So this transition, right, is typically 50 milliseconds, right? So for human being, right, this is only like a 0.05 seconds, right, which is very fast. But for microcontroller, this is actually a long time. So the microcontroller, Arduino, right, actually is able to capture this transition period. Okay? So 50 milliseconds, right? The typical clock in Arduino is about 84 megahertz, right? This one actually corresponds to what? Corresponds to actually less than 1 microsecond per instruction. Okay? So 50 milliseconds actually is a very long time compared to this kind of clock. So basically for Arduino, right, we are able to capture this kind of transition. Okay, how to do that? Right? Okay, so what we can do is So you have the microcontroller here, right? So last time we have this switch button here, right? So we connect this switch button to the digital input, right? Okay. And for this time, right, we want to connect this point to the analog input also. Why is that? Because you see, we want to capture the transition, right? Okay. Those transitions actually, if you want to take the exact reading, right, actually is the analog data, right? Because we want the every detail of the value, right? So that's actually is the analog data. So we want to use the analog pin, right, to capture the value. Okay, so for this point, for this purpose, right, we have to connect this point to the analog input. Okay, and the second thing is to use it as a data logger, right? We don't want to use the pin as an input one, right? So we want to connect by our additional resistor, right? Because the input one resistor is too high for this exercise. So we have to connect our own resistor here and to a VDD. Okay. So for this case, we cannot define our digital input, right, as an input one, right? Okay. So we only define as an input, right? And then we connect our resistor, external resistor, to VDD. And this resistor needs to be a low value, less than about 2 kilo ohms, right? Is sufficient. Okay. Then next, because we want to take the analog reading, right? So first we need to define our analog read resolution, right? Here you have two options actually. You can define as a 10-bit or 12-bit analog inputs. Okay, this basically is the resolution we have discussed. Right? So we have discussed for ADC, right? If we define as a 10-bit ADC, then you have how many possible values? If it's 10-bit, right? So it will be from 0 to 2 to about 10, right? Minus 1, right? So it will be, you will have 1024, right? Possible values, 1024. But if you define as your analog resolution, right, to be 12-bit, right? So how many possible values you have? So it will be 0 to 2 to about 12, right, minus 1. So you will have 4096 possible values. Okay. So that's one thing, right, you have to define for the analog reading. Okay. And for Arduino board, right? So in the lab, you always use the digital I/O, right? Right? You remember, right? So you take one of the pins from the digital I/O. Actually, on the other side of the Arduino board, right? Let me show you. So now actually it's a bit easier to discuss this one because we have already used, right? Okay. So you see, when you do the lab, right, you actually use this side, which is the analog I/O, right? So for Arduino Duo, right, actually you have about 50 plus digital I/Os you can use. And this side, if you look at the pin, right, this side the pin starts with A0 to all the way to A11, yeah. So you have actually 12 analog pins you can use. Okay, so this is the analog I/Os you can use. Okay. Okay. Before I forget, right? This week Thursday, right? You have lab 2. So for group 8, you need to come on Thursday morning to do the lab 2. So in lab 2, this week, right? Sorry. So in lab 2, right, you are going to use what we call a distance sensor, right, to do some testing. distance sensor, basically you can measure the distance that you can control. You can display something. Yeah. Basically that's the lab tool. Okay. So we have discussed the analog read resolution, right? Okay. Now you can use the analog read, right, from the ADC pin, right, and you store this value, right, to input value, right, into input underscore value. So you remember, right? So if you want to take the reading from the digital I/O, you use the digital read, right? So now you want to read the value from the analog pin, right? You need to use the analog read function. Right? You have used the digital read function, right, in the lab. For this case, for our exercise today, right, we need to use analog read because we want to read the analog reading. Okay, so what is the analog reading you are going to have? So basically, the reading actually is in terms of the 0 to, if you use a resolution 12, right? So the reading actually is from 0 to 4095. It doesn't give you the exact voltage values, right? Okay, what it means is, let me show you one. What it means is, if the voltage is 0, right, when you use the analog read function, right, you will get 0, right? When the voltage level is 3.3, right, when you use the analog read function, you will get 4095. So that's the maximum value you can get. Okay? So if it's read level, then it will be 2047448, right? Okay, so that means whenever you get a value, right, from the analog read function, right, so if you want to find out what is the exact voltage value, right, so you have to do a translation, right? Right. Let's say you get a value 1001, right? Just example, right? So this is the reading from the analog read function. If it's 1001, so what is the corresponding voltage level? So you have to do a translation, right? Somewhere here. Right? You have to do a translation. So how to do translation? So it basically it's something like this one, right? 1001 divided by your range, right? 4095.96, right? Times 3.3 volts, right? Right? So that will give you the actual voltage value, right? Okay? So it's like a scaling. So basically the analog read function, right, does not give you the actual voltage value, right? So any questions? Okay, right? Yeah, even you can check whether it's 4096 or 49. Okay. So now, let's say now you want to use the microcontroller as a data logger, right? Then you need to store the information. So what you can do is first, you read the data using the analog read, right? Then you write the data to the serial port by using the serial print line. Right? Okay, now the issue comes, right? So how fast is this serial print line? Right? Yeah. So now you see, if you want to do this kind of very fast capturing of the data, right? So you have to consider all these factors, right? You know, the analog read, right? Actually is very fast, right? Because your microcontroller is very fast, right? But how fast is your serial print line? Then that's the other question. See, so the serial print line, right? it depends on the bit rate you specify, right? Last time we say we use 9600 as the bit rate, right? So what is the meaning of 9600? 9600 means actually it's 9,600 bits per second. Okay. To capture a number, right? So how many bits you need? So if you capture a 12-bit number, right? So basically you need almost like 2 bytes, right? 1 byte basically is 8 bits, right? We have discussed, right? So basically you need like 2 bytes to capture the 12-bit number, right? Okay. So how long you need to capture the 12 bits? Okay. So we can do a simple calculation for this case. So we can do a simple calculation, right? So 9600 bits per second. This is bits per second, right? So if you want to capture 2 bytes data, so basically you have 16 bits, right? For 2 bytes, right? This is equivalent to 2 bytes, right? So how long you will need for this one, right? Okay, so 9600 bits per second is equivalent to what? It's like 0.1 millisecond per bit, right? About that, 0.1 millisecond per bit, right? So 16 bits basically is what? 1.6 milliseconds, right? So you need 1.6 milliseconds, right, to capture 16 bits. Do you agree? Do you agree? So this one actually is a long time, see? 1.6 milliseconds to capture only one reading. And we have discussed the switch bonds, right? The period for the transition is only about 15 milliseconds. So you need 1.6 milliseconds to capture one data, right? So this time is too long, right? So you have to think about a new way, right, to do it. One way is you can increase this bit rate, right? So the maximum bit rate we can use actually is 11500, right? Okay. So one way is you can use a higher bit rate, right, to capture the data, but still you can calculate for this kind of bit rate, right? You still need about 100 microseconds to transmit 1 byte. Okay, so 100 microseconds, right, to transmit 1 byte, and you need at least 2 bytes, right, for 12-bit data, right? Correct? Because 2 bytes basically is 16 bits, right? Yeah. So you need 2 bytes. So you basically need about 200 microseconds to transmit the data. Okay. So this time, again it's a bit too long, right, for reading. So what you can do is, can you think about a new way? So what you can do actually, you can capture first, right? You store all the data, then you print out the data, right? You don't do it like you read and print, right? Because now we have discussed the bottleneck here actually is the print, right? It's not the capture. The print is too slow. So what we can do is we save the data first, right? We capture first, then we print. Right? This one will solve the issue, right? Okay, now the next question comes, right? First we need to save a lot of data. We need to save a lot of data. So how to save? Let's say we want to save 1,000 data. How to save these data? So can we do this way? Yeah. So we declare a variable, right? Integer reading 1, right? You say 1. Integer reading 2, you say 2. Integer reading 3, you say the number 3. Yeah? In theory, it is correct, right? But if you want to save 1,000 data, you need to declare 1,000 times. Reading 1,000, right? You save. Right? So, yeah? So it's impractical, right? You cannot, it's impossible you declare 1,000 variables and you save each and every one, right? So what you can do is actually you can use array. What this array do, basically you declare, you use the same reading, right? So you use the same name, right? Readings. Then you declare as a 1,000 element array. So basically this array, you can store 1,000 integers. Right? This is much faster and elegant way, right, to store data. Because you know all the data, right, are from the analog readings. Right? So you can just use the same name, right, as a readings, and you declare the size of the array as 1,000. Then this array can store 1,000 elements, right? Okay, have you learned array before? Yeah? Have you? Yeah, this is a pretty important concept in the programming. So if you want to store a large number of data, right, yeah, you need to use arrays. Right? You cannot do this way. Yeah, you cannot do this way. Yeah. In this way, it's impossible to read, impossible to program, and also impossible to debug. So you have to use arrays. So then, the next question is, how do you differentiate between different numbers in this array? Basically, we use the different index, right? Yeah. So the first number, by default, right, for the index, right, of the array, right, it starts from 0. Right, it starts from 0. So basically, the first number will be reading bracket 0. The next number will be readings 1, 2, and 3, and so on. Yeah, I hope you understand this part. So for the array, right? So the first number will be reading, right? 0, right? Okay. So the next number will be reading 1, right? And so on. Okay. Okay, so now if you take the analog reads, right, the reading data, now you can assign your first reading to reading 0, right? The second reading to reading 1, and so on, right? The last number you assign it to 999, right? So this is the last element of the 1,000 element array. Okay. So now, you declare as your array as 1,000 elements, right? If you want to use the variable reading 1,000, right? Is it allowed? No, it's not allowed. If you do this way, right, basically you will get error because you exceed the range. Right? So you will have some error message, right? Like the array index out of bound, right? Basically you exceed your bound. Okay? So you are not allowed to use this index, right, which is exceed your range. Okay. Then how do we read in our data, right? So we cannot write 1,000 lines in this way, right? To read the data. Agree, right? Yeah. So what you can do, you can use the for loop, right? So this is the for loop you can use here. So you use the index, right? So index start from 0, right? Index less than 1000, right? So every time you execute, right, you increase your index by 1, right? So basically, if you look at your for loop here, right, you will execute 1000 times. So basically, you will read the analog reading for 1000 times. Okay? Then in this way, right, basically you have already saved your 1000 readings, right, into an array. Okay? And the analog readings, right, is very fast, right? It's very fast, right? So if you save all the data in here, right? So basically it takes very little time to wait. So basically you can capture all the transitions, right, for the switch bounds, right? And okay, the other thing I want to mention to you is if you want to change the number 1000, right? Yeah? So you don't want to fix the number, right? So basically, what it means is, let's say the next time, right, I want to capture 1,500 data points. The next time I want to capture 2,000 data points, right? So I don't want to fix this number, right? So what you can do is you can use the thing called preprocessor, right? So you can define this preprocessor directive, right? Data points as 1000, right? Then when you use, right, after you define this one, right? So when you declare your array, you don't need to key in 1000 here, right? You can just use this variable. This actually is not, I should not say it's variable. So this basically is like a predefined number. Okay? So that's a better way to say it. This is not variable. Okay. So this basically is a predefined number, data points, right? So now when you declare your array, right, you don't key in 1000, right? You use data points. And now for your for loop, right, index, you don't use index less than 1000, you use index less than data points. Okay, so the next time, if you want to change your data point to 2000, right, you just need to change here, the rest will be the same. Correct? This is a much faster way to write a program. Do you agree? Yeah. So the next time you want to change to 1500, you just only change this number. Right? The rest, the array declaration, the for loop, right, will follow, right? Correct? Because when you only change this one, right, the rest will change accordingly. Right? So this is actually a much better way to write your program, right? And easier for your modification and debugging also. Okay. Okay, so some of you may say, this one is actually like a constant. Actually, it's like a constant, correct? Yeah. So can I define as a constant integer? Right? Yeah, but this is not allowed. Okay. So you cannot define as a data points as a constant integer. Then you want to use in the array and etc. This is not allowed. So you have to use the define these keywords, right, to declare your this number. Okay. Okay. Now, so after you capture all the data, right, then you can print the numbers one by one. Like after you capture, then you can have a new for loop, right, to print out your numbers. Okay. Okay. Of course, you can capture also the time of the capture, right? So when you actually capture, you can use this function to capture your time. Okay. So basically, I have tried this program earlier, right? So let me show you what I have written here. And I will show you the props also.
full chat right there. Full chat.
Okay, so this is the program I wrote earlier, right? So what I have done is okay. First I define this pin right as my input pin. Okay, so this one you know. I don't define as an input one. I define as input. Okay, so this one initialize my serial monitor. Okay. And this one define my resolution for the analog reading, like 12 bits. So this one I define my this array right as a 1000 element array. Okay. So this one I did not use define, but it's the same. Okay. Then so I introduce some delay. Right. Okay, so now actually the problem is when do you need to capture the data? Actually, this is the problem, you see. You cannot capture all the time, right? Because for Arduino, right, you have limited memories to capture the data, right? So when do you need to capture the data, right? So I put a condition here. So basically, when the analog read, right? So analog read maximum value actually is 4095. So when you did not press the button, right? So actually the analog reading will be always very high value. So I have already checked, right? So it's somewhere it's 4095. Somewhere this value. So that means if I put a condition here saying when my analog read values right is bigger than 4000, right? That means I haven't pushed my button, right? Haven't pressed my button, right? So for this case, I don't keep the reading, but I wait here. So this actually is similar to what you have seen in the lab, right? What do we call this one? What do we call this one? Oh, we call it polling, right? Right? Correct? So basically, for this case, we are waiting for the push button to be pressed. Okay? So now if your analog read value, right, is less than 4000, right, that indicates you already pressed button, right? So now I want to start reading, right? So for this case, I save 1000 numbers, right? Use the for loop, right? I save 1000 numbers. So after I save it, right, I want to print out my data to the serial monitor. So after I print out the data to the serial monitor, then I can copy the number to the Excel and do the plotting. I show you my plot. Okay, so this program actually is very simple, right? So basically, I read the value first, then I print out the data. In this way, actually, I can capture the very short transition for the switch box. Okay? Yeah. So I show you my outputs here. Okay, so this is the data actually I captured. Okay? So you can see the transition, right? So actually, this value here, the y-axis actually is the analog readings. Right? So, and here actually is a different data points. Right? So you can see actually, it drops from the 1, right, very high value, right, to the low value. But you can see some transition here, right? You need some settling time. Right? when you press button, right? So this one actually shows you very clear the transition, right? When you press button, right? So that means your the value, right? The button value actually changes from 1 to 0, right? So you can see the transition here. Yeah. Is it okay? Yeah. All right. Okay. I think we have done the programming part, right? Okay. So next, I think actually we approach almost most of the technical discussions is almost done already. Yeah. The next lecture we only have power, right? We need to discuss the batteries, then that's all. Okay. Next, I want to discuss something more interesting, right? So we want to discuss the microcontroller and the microcomputer box, right? So you see the two words here, right? Microcontroller and microcomputer. So the Arduino you have used, right? Actually, what we call microcontroller, right? So in the market, right, there are three very common boards, right? The first one is Arduino, right? Arduino microcontroller. The second one actually is called MBAT, right? MBAT platform, right? This is from
Hidayah.
Using the ARM core, right? And the last one is called Raspberry Pi, right? Anyone you have used Raspberry Pi? Do you use anyone use Raspberry Pi for your final project?
Hidayah.
Okay. So Raspberry Pi, basically what we call is a microcomputer box, right? So do you know the difference between the microcontroller and microcomputer? This one actually we have discussed earlier, right? One of the big difference is what? The microcontroller don't have OS, right? So basically everything you need to write, right? You have to write from the beginning. While the microcomputers, right? You need OS. Right? Microcomputers you can use Linux, you can use Windows as your OS. Right? Do you agree? Huh? You are using the Raspberry Pi, is it? Oh, no, okay. So, which OS you use? Huh? Okay, so basically that's one of the big difference, right, between the microcontroller and microcomputer, right? Arduino is a microcontroller board. So Arduino, we have discussed this before, right? So Arduino basically is an open source single board microcontroller, and the hardware basically is an open source design, right? And with the processor, microprocessor basically is an ARM processor, right? And it has the onboard I/O support, okay? And you have used the IPE, right, for your programming. So we have different Arduino boards in the market, right? So in the lab you use Arduino Duo, right? Arduino Duo. So the most popular one actually is Arduino Uno. And of course you have other Arduino boards here, right? So some of the boards actually are small. For example, like Nano or DD packs. So this is the Arduino Duo you use in the lab. Okay, and we have also discussed for Arduino, right? Actually, one of the reason why it's so popular actually is because it supports a lot of shields. Right? So the Arduino board itself, right, actually it does not have a lot of functions. For example, like it does not have it does not support Wi-Fi, it does not support internet, it does not support some other it. Right? But
We need a daughter card.
if you want to have these functions, right, you can buy the additional shield block, right? Shield block, right? Then you can plug in with the Arduino block. Then you can have the functions, additional functions. Okay, that's actually is very smart way to expand your functions. So this is the wireless shield you can buy, right? And you have these auto shields to control auto. So if you look at the motor shield here, right, basically you can see a lot of big components here. Right? Basically that's the drivers, because you need to drive to provide the high currents to drive the motors. And Arduino, right, has a lot of applications. Right? Next, I want to show you a video, right? Okay. So this video basically is from the Arduino inventor, which is his name is Massimo, right? He is Italian. Okay. So the list of ideas here, right? Some of you are familiar, right? For example, like automatic light, right? Switch, right? And also the intrusion alarm, right? So this one actually is like very similar to what you are going to do in the lab too, right? And you can have some thermostats and robots, cars, Wi-Fi control cars, musical instruments, computers, LED, etc. Right? Okay, and Arduino, right, provide the interface to the MATLAB and Simulink. Right? So you know MATLAB, and actually it's very common software, right? Have you used MATLAB? Yeah. So MATLAB actually is a very popular software, right? So Arduino basically provides supports, right, to interface with the MATLAB. Right? So basically, whatever you write in the MATLAB, right, is possible to compile, then be used in Arduino. Right? Basically, you write the MATLAB, the codes in the MATLAB first, right? Then you can compile it, and you generate as a binary file, and you can use it as a Arduino file. Okay? So that's actually very useful, right? Because inside the MATLAB, right, you have a lot of toolbox you can use, like signal processing, whatever, like control toolbox. Right? Okay, so you can use the powerful toolbox inside the MATLAB. Right? After you did the programming in a MATLAB, then you can call it in Arduino. Right? That's very powerful tool, I think. Okay, so inside the MATLAB, right, there are 3 support packages for the Arduino. Okay, so the programs can be run in 2 modes, right? They can run as a standalone, right? And also you can run as a external mode. So this one, I think if you want to use a MATLAB without Arduino, you can explore further. Okay, next one to show you a video, right? This video is a bit long, right? It's about 15 minutes, right? But it contains a lot of information regarding the Arduino applications, right?
Molly.